It's time for the practice test for polynomials. We're going way back to finding the degree of each polynomial. And as you know, I try and go through a thorough explanation of all this stuff. So if you're looking for just the answers, this is going to be a long one for you. So this is 6x to the first power, y to the first power. The degree of this guy is 2 because 1 plus 1. Because it's on a single term, monomial, if you will, which is that word. And we don't worry about that guy. This one, this is 7, as you can see. That's an invisible 1, just like those. The degree of this one is 8, because 7 plus 1. The degree of this one, pretty straightforward, 2. Simplify each sum or difference. These guys are like terms. How do I know they're like terms? Because they both have an x cubed. This is like saying 6 boxes of a really particular type of cereal and 7 of the exact same type of cereal. So we will have 13 of those boxes of cereal. Over here, this is a different type of box. This is, hey, we got things in a box. And then we're going to subtract some things that are in this box. Well, if we go ahead and take them out of the boxes first, then, hey, we have the first box, which we're going to be subtracting from, right? And then I'm going to be removing 6 x's. I'm going to be removing 7 of whatevers. And so now you just combine the like terms. He has nobody that he's getting rid of. These guys are like terms. I will have a negative amount of those things left over. And then these are like terms. I will have -9. We're done here. Number 6, just a longer version. In fact, one of the reasons why I did this one the way I did is just because it can be helpful to go ahead and distribute that negative, so to speak. And that's why I did it. But if over here, if I'm just adding, I'm probably just going to look and be like term, 9x squared. Like term, 4x. Like term, -12. Because adding is pretty straightforward. There's no sign changes. Not really, you know. Simplify each product. We're multiplying. So I'm going to distribute 3x times x squared is, sorry, I already revealed the answer. 3x times x is x squared. 3x times 6 is 18x, and we're done. Now, we have reached the point of needing to distribute, but in a technically lengthier fashion. This distributing you've been doing since pre-algebra. This is the distributive property, and that we've also called it a different thing. We've called it FOIL. We did a box method. If you like the box method, cool. If you like foiling, cool. I've just kind of said, hey, listen, I would rather call it distributive and make sure that each piece from the left gets multiplied to each piece on the right. That is the FOIL method. But if you remember how passionately I said that FOIL breaks down as soon as you have something like this, then you'll remember why I don't love it, even though I technically just did it. Because here's what I'm saying. I want to make sure that x multiplies everybody over here, and that -2 multiplies everybody over here. That's the concept. So FOIL fails, so to speak, because FOIL stands for very particular letters. And anyway, my rant on FOIL is over. X times 3x is 3x squared. X times -4 is -4x. Done with that. -2 times 3x is -6x. -2 times -4 is +8. Now we can combine our like terms, and we are done. Number 9. You might think, oh, I will multiply by 2. Nope, you will not be multiplying by 2, my friend. Because what this 2 means is I have 2 of these. And now I will just distribute normally. Also, we kind of know a trick or a shortcut with that. And we'll remind you of that shortcut. It is ax, it's not ax squared. Yes, it is. It's ax squared plus 2abx plus bx squared. That's where I was remembering wrong. It's a squared plus 2ab plus b squared. And if you're like, what the heck? This is the equivalent. So you check this out and you're like, hey, that is a, that is b. So we would have 4x squared plus 2 times 4x times 2. And if you're like, well, that 2 right there. In fact, here, I'll do some color coding again. You know me and trying to color code. And then last but not least is plus 2 squared. So this will get us the answer, but if you don't remember that, that's okay, because you can 100% do this. And notice you're going to get the same thing, because 4x times 4x is 4x, the whole thing, squared, which looks like this, 16x squared. And then let's keep going. So 4x and 2 is plus 8x. 2 and 4x is 8x, and 2 and 2 is 4. So notice, oh my goodness, 16x squared. There it is. 2 of these will be 16, and then 2 squared is 4. So that is the final product. This will get you the same. You just would have to keep going. And if you're like, this one seems too complicated. Not really. This almost has just as many steps, right? This just took one form of recognition. This took another form. That's the difference. Speaking of recognition, we know that if we have something, a binomial like this, and then its neighbor is the exact same thing, except the only difference is that, then here's what happens. It ends up being this. We just know that. And if you're like, I don't know that, then go ahead and distribute. X times x is x squared. X times negative 5 is negative 5x. 5 and x is positive 5x. 5 and negative 5 is negative 25. And oh, look, those cancel, giving us what we knew. So, like I said, that's just some pattern recognition, so to speak. There is unfortunately no pattern recognition for these two guys. We just have to do the math. So here we go. X times x squared is x cubed. X times 5x is 5x squared. X times negative 6 is negative 6x. We're done with that guy. Negative 2 times x squared is negative 2x squared. Negative 2 times 5x is negative 10x. Negative 2 times negative 6 is positive 12. And we combine like terms to get x cubed plus 3x squared minus 16x plus 12. Done. Next, we just have 3 binomials. And so all this means is you're going to distribute, distribute, and then simplify what you've gotten. So you're going to get x squared minus 4x plus 3x minus 12. And now simplify that. So you get x squared minus x minus 12. And then you're going to multiply that by x plus 1. So I, just to keep things simple, like to multiply my binomials. So I'm going to do x times negative 12, x times negative x, and x times x squared. So that's x cubed minus x squared minus 12x. And then now, if you don't mind, I'm going to erase this. If I was doing this in my mind, like for myself, I wouldn't have drawn those lines. I would just kind of used my fingers and been like this, this, and this. So 1 times x squared, just like that. 1 times negative x and 1 times negative 12. And now you combine like terms. Those cancel. And we are left with this as our final answer. Find the greatest common factor of these monomials. So let's see. First, I'm going to focus on the coefficients. And I notice that they're all divisible by 3. So I think that's the go here. So 3 into 39, that's 13. And 3 into 96, let's see, that's 32. And 3 into 114, that is 38. And if you're wondering how I did that, here's just a little, like, I don't know if you've technically learned this or if I ever taught you this. 3 plus 9 is 12, and 12 is divisible by 3. 9 plus 6 is 15, and 15 is divisible by 3. 3 plus 1 plus 4 is 6, and 6 is divisible by 3. Fun. So anyway, our answer is going to include a 3. And then the next part is actually, that was the hard part. The easy part is now this. There's 3 x's, there's 1 x, there's 4 x's. So they have 1 x in common. And if you're like, what? There's 3, there's 1, there's 4. So they happen to have 1 x in common. And next, y to the 4th, y squared, y to the 3rd, that's y squared. How come? Because this one has 4 y's, this one has 2 y's, this one has 3 y's, so they have 2 y's in common. So here is your answer, 3xy squared. Next, let's see, is that 6 can go into both of those? I think it's 6, or is it, no, it's 7. Sorry, that's an unintentional 6-7 joke. Let's see, 7 times 6 is 42, 7 times 8 is 56. So it's going to be 7x cubed. How come? That one has 5 x's. That one has 3, 1, 1, 2, 2, 3, 3, 3. There is your answer. Factor the polynomial if possible. If it can't be factored using integers, write prime. So prime is what happens when it cannot be factored. Okay? And if you're like, but can't everything technically be factored? Using the quadratic formula, yes, but I think the understanding here is if it can't be factored using integers, right? Because square roots and imaginary numbers are not integers. Number 1, in fact, here, I like number 1 because number 1 is only factorable with like the number 1 rule. And the number 1 rule is factor out the greatest common factor. And this is number 1 for 2 reasons. 1, because it's number 1, and it's number 1 because we often forget it. So you might look at 15 and go, well, you can't factor that because there's no x squared. But it has the greatest common factor of 4, and that's it. So you're going to get 3x plus 5y, and it's done. Number 16. Let's see. They all, in fact, just like way over here where I said I'm going to start with the coefficients. That's what I'm going to do every time. 16, 6, and 10, they've all got a 2 in common. So that's going to leave me 8 and 3 and 5. And now the x's, they've all got at least 1 x. So you know what? I need to make some room over here. 2, they've all got at least 1 x. So I'm going to have x cubed, x squared. And then last is the y's. They all have at least 1 y. Let's see. That is it. We are done. Now, one thing I like when I do color coding things is it kind of gives you a visual of like, look, 8, 3, and 5, pretty conclusive that they don't have anything in common. 3 is prime, 5 is prime, 8 is 2, 2, 2. There's 3 x's here, there's 2 x's here, there are no x's here. There's a y here, there's no y's here, there's 3 y's here. So we're done. Next. Well, this one jumps quickly into the diamond or the X or whatever we've been calling it, where this is A times C and that is B. And if you're like, wait, when did it become A times C? Well, it's always been AX squared plus BX plus C. It's just that we don't always have an A. In fact, you might have not even seen me erase that. We don't always have an A. If there's not a number written there, it's because it's 1. But sometimes we do have an A. So anyway, this right here is 14, and then B is 15. So now these two sections, again, I'm explaining this as if you have no clue. These two sections are now the factors of 15. Just kidding. They're the factors of A times C. A times C factors. A times C factors. And we want them to add and subtract to equal B. That's why I put the equal sign here. It equals this, and the equal sign here, it equals that. So I'm going to write all the factors, even though I don't really have to. The factors of 15 are 1 and 15. 1 and 14. Will that ever give us 15? Actually, it very well could, but let's keep going just in case. 2 and 7, will that ever give us 15? No, I'm pretty sure that will never give us 15. But if I had 1 plus 14, that would be 15. So guess what? I get to take these guys and just write my answer. I'm done. And if you're like, wait, I'm a little lost on why. Well, why don't you just distribute now and you would get x squared plus 14x plus x plus 14. You would get this, okay? And I'm pretty sure, 99.9% sure, all of you are 100% fine with how to do this. Let's keep going. 18. In fact, I'm going to kind of speed up on my explanation part just because of how much I'm pretty sure you do understand that. 18. It's an ax squared plus bx plus c moment. We have negative 22 and negative 9. The factors of 22 are 1 and 22, 2 and 11. If we had positive 2 and negative 11, that would give us negative 9, and we multiply them, we get negative 22. So I can just jump straight to x plus 2, x minus 11. Done. Oh no, A is not 1. And I say oh no, just because that means we're going to have a little bit more work. This is A times C, right? This is our B. And it's the same idea. What are the factors of 24 that give us 10? Well, it's not those two. Maybe those two. Not those two. Maybe those two. Okay, well, let's figure it out. 2 and 12 would have to be like a negative 12 and negative 2 and a positive 12. But check it out. We have only positives here, so that's why those are not going to work. Those didn't work just because. These don't work just because. Positive 4 and positive 6 are going to work, though. So now, when you have this scenario, which is that scenario right there, here's what you have to do. 3x squared. Notice how I literally just wrote that here, right? That's the same thing. In fact, I like that highlighter thing so much, I'm going to do it right here. I'm just going to write 8 right there. But you know what I'm going to write in the middle? Plus 4x plus 6x. And if you're like, where the heck did that come from? Right there, right? And if you're like, that's crazy talk, it is a little crazy, right? And now what we're going to do is look at this and see what factors does that group have. Well, they both have an x in common, and that would now be 3x plus 4, right? And now we're going to look over here and say, how could we make this be the same as that? So I notice if I factor out a 2, mainly because they have 2 in common, I would get, let me switch colors because I like doing that, 3x plus 4. Wait a second. We now officially have this is the same as this, right? So what that means is that is what is in common to this term, and that is what is in common with that term. I can factor out things that they have in common, which means I will be left with x plus 2. Now, I messed up a little bit of my color coding by making this yellow, but I don't really care, because this x is this x, and this 2 is this 2, okay? We're done. That's the answer right there. A, C. Let's multiply them, and we get negative 36. There's our B. The factors of 36, I don't always list them all out. In fact, I'm pretty sure you guys know that because, I mean, we've just done a lot of these, right? And I think a lot of you kind of just know, hey, this is probably what's going to happen. So negative 4 and positive 9. There was 2 other terms, 6 and 6, but those aren't going to work. So again, we're going to have 4x squared, that minus 9, and there's going to be negative 4x plus 9x in the middle. This set, those 2 terms have 4x in common. So this is now x minus 1. These 2 terms have a 9 in common. That's now x minus 1. They both have an x minus 1 in common. And what will be left behind is 4x and positive 9. That's it. What? Only 2 terms? Well, one thing that tells me is I should watch out for this. And 2, it tells me to watch out for something that looks like this. Because that is something called a difference of squares. And it factors immediately to look like this. Hang on, I shouldn't have written it as ax squared. Let me rewrite that. It looks like that. So that now it will look like this. A plus b, a minus b. It will just look like that. And in fact, what is the difference of squares? Well, guess what? This is likely going to be an example of that. So what I'm going to do is, actually, no, it won't. These are both divisible by 3, so I take out a 3, and I get 4. Oh, just kidding. It will. And I get that, right? Well, now, 4 is a perfect square of 2. 9 is a perfect square of 3. So here's what's up. That 3 just drops, and this is now 2x minus 3 times 2x plus 3. So do you see how this looks kind of like that? And hopefully you definitely see how that follows up with it. Next. Oh, and the emphasis here again was factor out the greatest common factor, but also if it has just 2 terms, see if it looks like that. Because if it does, cool. Notice how this one did not look like that. So it did not factor the same way. Cool. Next, they all have a 5 in common, which is just going to make our life easier if we factor out that 5. And if you're like, why would it be easier? Well, because 3x squared plus 2x minus 8, I can do 3 times 8 in my head. I can't really do 15 times 40 as well. You know what I mean? I can do the 3 times 8 much easier. And we need to get 2. So the factors, let's see, I bet that's 6 and 4. A positive 6 and a negative 4. Sounds good. So this 5 is just going to be out front, kind of being annoying, just so you know. 3x squared minus 4x plus 6x minus 8. The only reason I put my plus 6 right here instead of right here is just because I don't want to mess with a negative over here. And in fact, I don't know what he means. Well, 1, I've explained that one a few times, and I think most of you have seen it, but, you know, anyway, I'll show you. So this group right here has an x in common. So that's now 3x minus 4. And if I had left this as a negative, then I would have to factor out a negative. But since this is positive, since this is positive, I don't have to. And if you're like, but wait, why? Because 3 is positive. So all I have to do is factor out a 2, and I have 3x minus 4. Okay? Again, I'm not going to really go into the details of that just because I have explained it before, and I don't necessarily think you need for me to explain it again. But if you'd like to, I'm going to go ahead and put this one on you. Come ask me about it. All right, 23. They all got a 3 in common. Let's factor that out. X cubed minus 3x squared plus 4. So this one is done from this point. Let's see. I don't think there's another way we can go about this one, because this is not, let's run why not, ax squared plus bx plus c. It's not that, right? Because that's squared, and actually that's our squared guy, right? We can't factor it by grouping, because it's like, well, yeah, there's this group, and if we take out an x squared, okay, we'd have x minus 3, but then we just have a plus 4 hanging out there, right? So we can't do that. So this is the answer, believe it or not. Number 24. They all have 3 in common. Let's see if they got anything else. 3 and 3 is 9. 3 and, is it 14? Hang on. Yeah, 3 and 14 is 42. And just kidding, they don't have a 3 in common, because 49 is not divisible by 3. Hang on. I don't think you can factor out anything from the coefficients, because this is only divisible by 7. 7 times 7 is 49, and this is 6 times 7, but this is 9, which is not divisible by 7. So, okay, they have an x squared in common, so let's take that out. And we get that, we get that. Okay, so from here, this fits. Have we even done one like this today? We have not done one like this today. I just want to double check. Cool. All right, here's our first one like this today. This fits a pattern. And if you're like, I don't see a pattern. Well, perfect square, okay? And what that looks like is it's a squared, didn't need a parenthesis there, is it's a squared minus 2ab plus b squared. So, in our scenario here, a squared equals 9x to the 4th. Okay, so what this looks like down here is this is now 3x squared minus 2 times 3x squared. And then if you're like, well, what's the b part? B squared is 49, so that means b is just 7. And so that makes this 7 squared. Okay, now if you're like, I don't really want to do that. Well, okay, that's your choice. I'm just going to tell you the answer. Oh, wait. I don't need to simplify that. I need to actually tell you what this turns into. That turns into a minus b squared. So it's actually simpler, because now this is 3x. Hang on, I'll keep the colors the same. This is 3x squared. Let's see, minus, that's an awesome minus 7. Done. Now, don't forget about our x squared up here. So this is the answer. Now, if you're like, oh, I'm not going to remember this, and I'm not going to see that. Okay, that's cool. Factor it with the diamond method. It will work, promise. Factor it with that thing. It works. Let's do the next one. They all have a 2 in common. So we take out a 2, and we get x squared plus 6x minus 7. I think this factors pretty nicely. It's negative 7 and 6, so that's negative 6 and minus 1. No, it does not factor any further because negative 6 and wait. I don't know why. Hang on. This works. Just kidding. I mixed up my 7 and my 6 here. Okay, the factors of 7 are 7 and 1. Right, there we go. Now we fixed it. Positive 7, negative 1. That 2 is out front, and so we're just left with the rest of our stuff. X plus 7, x minus 1, and we're done. And by the way, I've said it before, but just in case you're like, I'm not so sure about if that's right or not. Remember, just distribute. There's x squared. There's minus x. There's plus 7x. There's minus 7. That's x squared plus 6x minus 7. And that's what we had right here. So that's why this is an okay answer. 26. Hey, cool. It's a binomial. That's a perfect square. So is that. And one important thing is they are being subtracted. So this is very quickly 5x minus 8. 5x plus 8. And if you're like, what? We talked about it right here. Difference of squares. We have done some factoring. Now let's do some solving, which, believe it or not, requires factoring. So this binomial equals 0. Number 1, I don't know where I'd put a star. Number 1 and star. It's gotta equal 0. So check, we equal 0. Check, we equal 0. Oh no, it doesn't, but we can make it equal 0. So anyway, what are we going to do here? Well, let's factor it. They have a 2 and an x in common. That leaves us with x minus 3. And now what's going on is 2x is multiplying x minus 3, yeah? So if 2x were to equal 0, then this whole thing would equal 0. Well, guess what? If we divide by 2 on both sides, we get that x equals 0 is a solution to this. And that means that x equals 0 is a solution to the whole problem. And now the other part, x minus 3, if that equaled 0, and you add 3 to both sides, then 3 would be a solution. And in fact, I don't understand. Put a 0 right there. What do you get? You get 0. 0 times this would equal 0. Put a 3 right here. You get 3 minus 3 is 0. 0 times 2x is 0. They all have a 2x in common. So we get x squared minus 3x plus 2 equals 0. This can factor to x minus 2, x minus 1. I know I didn't do the little diamond math thing, but some of them you can just do in your head, and that's what I just did. This is x equals 0. This is x equals 2. This is x equals 1. We're done. Over here, I said it didn't equal 40 or 0, but we can make it equal 0. How? Subtract 40. Pretty simple. 3x squared plus 19x minus 40 equals 0. Shucks, they don't have anything in common, so I've got to do 3 times 40, which is negative 120, and I want it to equal 19. So let's see. There's 2 and 60, 3 and 40, 4 and 30, 5 and, oh gosh, I can't think, 24? Hang on, is that 24 times 5? That's 20 plus 100, that's 120. And I think that's actually it, because I need a positive 24 and a negative 5. So I'm going to have 3x squared minus 5x plus 24x minus 40 equals 0. those have an x in common. 3x minus 5. Those have an 8 in common. So 8 is 3x minus 5. The whole thing factors to look like this. And that equals 0. So now I can tell you that this one is x equals negative 8. And if you're not comfortable solving this one in your head, that's okay. You can write it all out. There's no harm in that. Add 5. You get 3x equals 5. You divide both sides by 3 and you get 5/3. Those are your two answers.